Dad, why do things around us move, and how can we describe this motion?
Motion is simply the change in position of an object over time. For example, the movement of cars. People walking. Or the planet revolving around the sun. Motion is around us. Moving on, there are three major types of motion, which are linear motion, rotational motion, and oscillatory motion. Starting with the first type of motion. Linear motion is the movement of an object or body in a straight line. For example, a car driving down the road in a straight path. Rotational motion is the movement of an object or body around a central point. For example, rolling wheel. Oscillator motion is the to and fro movement of an object or a body. For example, child on a swing. There are some important terms in motion that we must understand, which are speed, velocity, and acceleration. Speed tells us how fast an object or body is moving. If a car is traveling at 60 kilometers per hour, that's its speed. This indicates speed, but add direction to the speed. For example, a car traveling at 60 kilometers per hour north. And remember, the major difference between speed and velocity is that speed indicates how fast an object is moving, while velocity indicates how fast an object moves in a particular direction. Acceleration. Acceleration measures how quickly an object's velocity changes. For example, in the year 1687, a scientist called Isaac Newton introduced the laws of motion. We called them the Newton's laws of motion. There are three Newton's law of motion. Newton's first law of motion states that an object at rest remains at rest unless acted upon by an external force. For example, a ball will sit still unless it has been kicked or acted upon by an external force. This explains the first Newton's laws of motion. Newton's second law of motion states that the force applied to an object is equal to its mass multiplied by its acceleration. For example, a rocket gaining speed as the force increases. That is to say, the higher the force, the higher its acceleration. This clearly explains the Newton's second law of motion. Moving on, Newton's third law of motion states that for every action, there is an equal and opposite reaction. For example, simple pendulum bob hitting each other. Notice that when the bob at one end hit the other bob, they moved in that direction. But later on, the bob at the other end hit the remaining bob, and they moved in the opposite direction of their first movements. That is to show that for every action, there is an equal and opposite reaction.